Ladies and gentlemen, distinguished guests and valued members of National Cannabis Industry Association, welcome to today's Industry Essentials webinar, Adapting to New Economic Realities, How Co-Solvent Extraction Can Minimize Your Processing Costs and Increase Your Margins. My name is Brian Gilbert, the Deputy Director of Events here at NCIA, and I'm delighted to be your host for this insightful session. For those tuning in for the first time, NCIA's Service Solutions series provides an exceptional platform for business owners like you to explore premier products, services, and industry solutions directly from our network of established suppliers, providers, and thought leaders. Today, we confront the economic realities of the cannabis industry. While it may have once seemed like a pathway to printing money, the landscape has evolved and everyone must now navigate the fundamentals of business to thrive. Processing costs are a critical concern amid growing competition and price compression. In this mature market, every penny counts, making it vital to optimize your operations. To address this challenge, we have gathered here to delve into a transformative and often misunderstood solution: co-solvent extraction using CO2 and small, metered volumes of ethanol. Our esteemed guest speakers, Jason Laronde from Vitalis and Mark Webb, a passionate chemist, educator, and extraction specialist, better known as the Aroma Science Guy, will shed light on this innovative approach and its potential impact on your production cost and profitability. So let's embrace the opportunity to explore this cutting-edge technique, streamline your operations, enhance profitability, and maintain the consistent product quality your customers expect. So without further ado, I'll hand it over to Jason Laronde and Mark Webb to take us on this enlightening journey today. I'll stop my screen share, Jason, and you can pick it right up there for me and kick today's presentation off.
Thanks, Brian. Appreciate your time. Just going to go ahead and start our presentation here. And of course, we love active engagement. So if anybody would like to chime in with a question, a concern, has a comment on anything that we talk about today, feel free to drop it in that chat and we'll be sure to get to as much of it as we can today. Of course, if we can't address any of that in the chat today, feel free to reach out to either myself or Mark. We're almost always available and happy to talk to you about some of the really interesting things that Vitalis has been working on and has already brought to market. So the first thing we want to talk about is, at Vitalis, we provide extraction and post-processing, clean tech and CO2 capture solutions in some really cool markets. Our experience with the cannabis industry actually spans nearly a decade and includes helping some of the world's largest processors and international brands create CO2 cannabis and hop concentrates, as well as many other proteins, aerospace, and pharmaceutical products using our equipment. We're a vertically integrated original equipment manufacturer of CO2-based technologies with in-house R&D, design, engineering, production, and support. And our mission is to help producers thrive while becoming more resilient and future-proof. We do that by utilizing unique properties of CO2 in a number of different ways, like extracting and refining natural ingredients from biomass, or employing CO2 as a heat transfer fluid as a natural refrigerant, or recovering and distilling CO2 for repeated use in applications ranging from extraction to brewing and high-proof spirits. We have over 150 installations on 5 continents, and our CO2 expertise is recognized worldwide. I am Jason Laronde, Sales Manager at Vitalis, and I am your host for today's webinar. I joined Vitalis shortly after its inception in its lead up to the federal legalization of cannabis in the Canadian market. And since then, I've had the privilege of working on nearly 100 deployments of our 150 installs across 5 continents, with customers ranging from the largest multi-state operators to multiple EU GMP certified facilities actively distributing pharmaceutical products across the globe today. I have been a key member of the launch teams that have brought commercially successful co-solvent extraction to the market, automated inline refinement, and R744 natural refrigerant technologies to the cannabis and many other industries. Today, I am privileged and would love to welcome Mark Webb, renowned chemist, educator, and extraction specialist, as a special guest. Mark.
G'day, guys. And if you hadn't worked out, I'm from Australia, the land down under.
So since the early days of the cannabis industry, the wholesale and retail value of cannabis and its derived products have steadily declined, and what was once referred to as the heyday has now reduced to levels that make profitability extremely challenging, particularly with equipment and processes that at one time made sense, or because the economics were so disproportionately profitable, basic business fundamentals didn't really matter to be profitable. This, along with many other factors such as taxes, regulation, a flood of other players to the market, and increasing investor sensitivity, has had a serious impact on the value and perceived value of companies producing cannabis products. In that time, the cost of goods sold has increased steadily. Consumers and consumables such as extraction solvents have increased significantly, and the average wage and benefits to employ the people that make these products possible has risen faster than nearly any other period in history. As a result, many producers find themselves at a crossroads between their cost of goods sold and the price compression that for many businesses clinging to their current methods of production is unsustainable. New technologies that reduce the time to produce, decrease the headcount required to produce, reduce consumables, eliminate steps in post-processing, and allow producers to manufacture more SKUs with less equipment is one of the largest levers forward. There are a number of processes that are available, with the most common in the traditional sense being CO2, ethanol, hydrocarbon, and solventless methods. Every processor will have a champion that will tout the benefits of one or the other. Ethanol has been a great go-to strategy for some of the largest players in the industry, but with the trade-off of extremely costly solvents, high energy costs to refrigerate, recover, and purify this solvent for reuse, and the need for facility safety improvements that can evaporate any cost savings that the capital equipment originally afforded them. CO2 monosolvent, or CO2 by itself, or supercritical CO2, has always been known for its selectivity, and in some operations, its terpene retention and its product purity, but usually with extremely high capital equipment costs upfront and additional post-processing equipment downstream. Hydrocarbons extraction, while capable of making some extremely desirable products, in almost all cases carries with it limitations with scale, some of the highest and most costly facility safety improvement requirements in the industry, and in many jurisdictions, it's not even permitted. Above all, everything I've just mentioned is the same calculus that every player in the industry is weighing. So if you think that you have an edge in your market using these common methods, understand that your competitors have the exact same options available to them with the same economics. Solventless extraction can create some extremely high valuable products with minimal equipment, but the trade-off of catering to a smaller overall market segment. Vitalis launched its Cosolvent injection system, the first of its kind to use a unique combination of extremely low pressure and low pressure subcritical CO2 and very small injections of ethanol to produce provide its customers with selectivity, scale, and speed where other manufacturers have failed to deliver. Now, data is king, and here we show some of our early R&D results from the development of this product. One of the first unlocks was the rate of injection. At even 2% injection of ethanol compared to the volume of CO2, extraction times were already significantly reduced while retaining an incredibly high product quality. At 3%, product quality was retained and speeds were increased even further to achieve nearly 90% recovery of available cannabinoids in only 45 minutes. And at just 4%, increasing the productivity slightly more, sliding the recovery curve further to the left, allowing consumers to weigh the value of their input product, the value of their output product, the additional cost of the small increase of consumables going from 3 to 4%, and the value of the few minutes saved in labor to determine where the cost to produce versus the value of produced intersect. Every market is different, but customers can now achieve greater than 90% efficiency with a cost to produce that was previously unattainable. What kind of cost to produce? Well, Vitalis doesn't want to present you with shiny marketing material. We'd rather show you the math and have extremely comprehensive calculators that demonstrate the economics of the process. Every variable, kilowatts of electricity, labor headcount to operate, vessel load values, consumables, maintenance intervals. These are all hard values for every piece of our equipment. The variables, though, are yours. What is your labor rate? what is your rate for electricity? If you provide us with these and a few other figures, we can calculate to a pretty accurate estimate of what your total cost to produce will be. And here is an example of an actual lab running our Cosolvent system today. And the cost of electricity, labor, consumables, and maintenance to run the extraction operation calculates to just 5.2 cents per gram. Tell us your cost of your input material and the value of the extract that you then would produce and sell into your market. And excluding facility overheads, we can give you a pretty good idea of what your margins will be. And in any scenario, if your extraction process costs you more than 5 cents per gram, you need to call me. So what does this process look like? The extraction operation uses CO2 only and extremely low pressures and temperatures, far lower than any other manufacturer on the market, to pull a terpene primary extraction. This is performed in only a few minutes and allows you to create a high purity terpene that was never subjected to ethanol, going through no post-processing, and these are set aside. The extraction system then starts the cosolvent injection to accelerate the extraction process to run times that were previously only available to operations like hydrocarbons and ethanol. At the end of the SOP, the ethanol injection is stopped, and the CO2 extraction phase, called the ethanol reclaim, essentially extracts whatever remaining ethanol is in the biomass. This leaves you with a depleted, dry, ethanol-free waste product that does not need to be remediated, dried, or processed in any other way, and can be carted away just like any other solventless or CO2 raffinate. Finally, the CO2 that remains in the system under pressure is recovered so that the system can be safely opened, unloaded, and reloaded for the next cycle. Nearly all Vitalis configurations have at least 2 extraction vessels, so the next vessel can already be preloaded in preparation for the next cycle. What used to take an entire shift using only CO2 can now be completed from startup to shutdown in about 80 minutes, and much less if terpenes are not a target compound during that operation, or when the second vessel is loaded and ready to cycle. Over the course of a regular workday, what maybe would have been 2 extractions can now be 7 or more. And if your operation isn't looking to 4 or 5x your throughput, this means that you can consider a much smaller piece of equipment compared to other offerings on the market and still achieve the same real world throughput. And of course, with a large piece of equipment with the idea of scaling in the future in mind, you could just have an operation that did your 2 extractions and be done by lunch. These are some examples of the terpene fractions retained by the first phase of that extraction operation. Set these aside and formulate them back into your refined extract downstream in the lab. Save them for other products that you're making. Say, for example, if you're manufacturing a product that doesn't require flavor and aroma, like a patch or an inhaler or a suppository, or sell them to your competitor down the street who is running an extraction process like ethanol that can't preserve terpene products effectively. The consistency of cosolvent extract is extremely easy to work with, and what was previously high in wax content now is a homogenized mixture of extract and ethanol that can immediately be processed in the lab. There is no additional ethanol to add in the lab. There's no post-processing homogenization. Vitalis cosolvent extract goes straight into the freezer, and with a wax content of between 1% and 2%, and about half of the ethanol used compared to traditional CO2, precipitation, filtration, and solvent recovery takes hours, not days. If this were a cryoethanol extract, the ethanol to be recovered and the energy required to do so could be 4 and in some cases 10 times the amount of a cosolvent operation. And other co-extracted products, when using things like cryoethanol, like color or sugar, being a problem for lab equipment and other processes downstream, are not an issue with Vitalis cosolvent extraction system because of our design, demonstrated with analytical testing. Some of the largest multi-state operators in the US have standardized their extraction process on the Vitalis cosolvent injection system, with one executive sharing, "We have nearly every extraction method available in our labs spread across the country. And in every analysis we've done, the Vitalis outperforms in product quality, throughput, and cannabinoid recovery by a country mile. Large commercial producers in Canada, like Christina Lake Cannabis, who is one of the largest producers of transacting distillate nationally, were early adopters of the technology and continue to churn out gallons of extract to the Canadian market day after day. The Cosolvent injection system is available as a standalone product and can easily be added to any Vitalis that's currently in the field, either our Q or R series. And Vitalis has just launched its latest generation of extraction products in the Max series, spanning units as small as a single 10-liter to multiple 200-liter columns. And remember that due to the extremely fast processing capabilities, liter for liter can no longer be the comparison. A Vitalis 10-liter would need to be stacked up against a 50-liter or larger from a competitor to match the throughput, affording you the ability to save footprint, utilities, and upfront capital cost compared to the traditional way of processing. In addition, Vitalis manufactures completely automated inline refinement skids that mate directly to the output of the extraction to give you the option for a completely end-to-end, fully automated plant to product with a single operator. Using our knowledge and expertise in handling CO2, we also have a broad range of packaged and custom R744 or CO2 natural heating and cooling heat pump solutions in response to increasing restrictions on the use of synthetic refrigerants and the extremely high performance that R744 affords. And finally, our newest product line to just launch is the Freecovery, designed to mate to nearly any CO2 source for the capture, cleaning, and on-site storage of capturable CO2, such as the output from a competitor's extractor that dumps large quantities of CO2 to the atmosphere, fermenters in breweries and high-proof spirits, or industrial processes. At Vitalis, we strive to bring truly beneficial technologies to our customers. We try to prove the performance of our equipment to our customers to show what it can actually do to your business. The outputs that you get from our account managers and our engineers when selecting a piece of equipment for your particular operation comes with data that you can confidently plug into your ROIs and your business plans, and feel confident that Vitalis, as a global manufacturer and supporter of our customers with sales, service, and support across the globe, that Vitalis is an excellent partner for you. And with that, I would love to open the floor to any questions that anyone might have.
Right. Perfect. Awesome. Thank you so much for going through that, Jason. I loved all the visual imagery that you had incorporated into that presentation. So thank you for working with your team to develop all of that and present it in such a visually appealing way for the audience members. Perfect. We're starting to see some questions be posted to the Q&A board. So thank you to the audience members for the engagement in the session today. We're going to dive right into this and bring Mark into the conversation. So I think since we got some questions coming in from a few different folks, I'll just do chronological order, unless the other audience members want to head over to the Q&A board as I directed at the beginning of the session and give an upvote to any of these great questions that we currently have logged so far. So I'll dive into the first question that was posted by Crystal Howe just about 10 minutes ago. So I think this probably lined up with the portion of your presentation you were giving, Jason. But the first question that we have here is, when expanding CO2 with ethanol, can the presence of ethanol in the final product ever be totally eliminated? And then a comment here from Crystal, it can sometimes leave a faint sweetness. So can you elaborate a little bit more on that, Jason and or Mark?
Yeah, Mark, go ahead. Like, you've actually worked with this before.
Yeah, so look, even if you're doing monosolvent extraction, you end up using ethanol in the post-processing phase. So it's not much different. And basically, you can take the extract with the CO2 and the ethanol in it. And as you saw in the presentation, it's a nice, relatively clear liquid. It doesn't have a lot of waxes or colors in it. And then put that in a post-processing skid. The Vitalis skid will do this, will strip it right down, or into a molecular still or a rotovap, whatever you want, and reduce that ethanol right down to the level that you want to get it to. So you can basically strip it right out. I've been doing some work with it also of taking ethanol right down and then using water washing to wash the remaining ethanol out of it, because ethanol will form an azeotrope with water. It binds with it and forms a stable molecule. And we do this in the aromatic world as well. If we've got some aromatics that are a bit smelly, we will wash them with water, strip them out, usually with some ethanol. It's a process in sandalwood to remove some of the less melodious or more melodious notes out of the Australian sandalwood oil. So yes, you can strip it right down, and you can get it out by using some relatively easy to do technique, way simpler than having to go through refrigeration, freezing, short path, et cetera, that you would normally do. So it's a very simple technique. How do the flavors from CO2 and ethanol compare? Look, I don't do a lot of work in cannabis, so I can't speak to that specifically, but in other aromatic plants and other botanicals, it doesn't affect the flavor profiling much at all, because again, you can strip that ethanol away. Ethanol doesn't have much of its own flavor. So I find that you end up with a cleaner product. I've just been working on some stuff today that the flavor profiling with ethanol in it was superior to without, which is interesting. Hydrocarbons and solventless extraction, simpler and less expensive? Yes, they can be. Hydrocarbons, unfortunately, do have some negative connotations in end product use. A lot of regulatory bodies don't like seeing hydrocarbons in product. There also is the flammability issue. The system that Vitalis uses with the Cosolvent ethanol, it's a negative pressure, it's a contained skid or unit. So there's no fire risk, there's no explosion risk like there is with hydrocarbons, or with having to process traditionally with ethanol, with the massive amounts of ethanol you've got laying around in a facility. So it's got to be fire rated. So this is a much simpler, easier technology. It's a smarter application. And Jason can speak to the regulatory side of it. He's got all the necessary stamps, and fire marshals love this gear because it's simple and easy, and it makes their job so simple.
Yeah, I know, Luke, we were, Jason, that we were sort of touching on that a little bit before we went live. From Vitalis's perspective, can you sort of talk about the safety elements that are naturally sort of incorporated into this equipment set, and some of the benefits that can provide as well?
Yeah, this product, when it was originally developed, we launched this product about 2 years ago. And we knew right away when we first developed that product that it was developed in such a way that it could be bolted directly onto any of our customers' existing pieces of equipment. So it was meant to be an add-on product to existing equipment in the field. And once we've satisfied all of our existing customers' desire to have this product in their labs, we knew that no one would ever choose the slow option ever again. And so that's why our Polaramax has co-solvent capability built directly into the skid. But we knew right away, first hard stop was if this equipment was designed in such a way that when it rolled into the facility, it also would require the facility to have any sort of Class 1 Division 2 facility safety improvements, that it would be kind of a hard stop right away. Like that's really something that a lot of folks are trying to avoid. These are active production environments. There's really no ability for them to just cease production so that they can install ventilation and upgraded lighting and electrical and everything. And so when we developed the product, we developed it to be a completely sealed enclosure. So you'll see in our co-solvent units that they are completely wrapped in stainless steel. This is a negative pressure vessel that is ventilated directly to the outdoors. And the carrying capacity, including its basin in the bottom of the machine, is 115% of the total possible volume of any fluid that could be in the system at any given time. So it exceeds the total volume that anything could leak, even if there was a catastrophic failure of a fitting and it was to just leak everything all over. It wouldn't go all over the floor. It would stay inside the unit. And what this does is, it's never vaporizing inside the unit's operating functionally. It's not leaking anything. But if that was ever to happen, it ventilates to the enclosure, which is then in turn ventilated to the outdoors. And so what this allows our customers to do is roll this into any building. Whether it was designed with the idea of having CO2 and then they heard about this product, they can just buy my CO2 machine and put a co-solvent system on it. If they own a Vitalis already, they can buy this and roll it right through the same door, plug it into a 110 volt outlet, plug it into air, and they're making co-solvent extract the next day. There even are scenarios where this could be added to a competitor's CO2 machine with a little bit of a think. But yeah, again, as long as we develop this product and we didn't need to give our prospective customers that roadblock of like, what about all of the other stuff that needs to be done to make this allowed? And then going through the third-party peer review to be able to generate all the documentation that satisfies local fire marshals or inspectors on that this is an intrinsically safe piece of equipment that's been designed with additional headroom for NFPA standards. This can roll into any space and plug in, and it doesn't require the facility to be improved to fire code unless there's some unique local county that says like, hey, or a fire marshal that doesn't understand. We do our best to try to provide as much documentation we can with those guys. But this is a really neat device. Like if you have an ethanol process, you need to build a C1D2 room. If you have a hydrocarbon process, you need to have a C1D1 booth. And these are all things that more or less need to be kind of calculated into the cost of the equipment.
Yeah.
The equipment that I buy might be half the price, but then the room it needs to go in is twice as much. So it's, you know, kind of a wash, right? This is the equipment. We plug it in, we turn it on, we start making extracts, and some of the largest players in the industry now standardize on this process.
Yeah, that's amazing. We've been focusing on and from some of our internal programs, we've been covering a lot of the employee safety considerations that need to be made throughout different types of extraction processes. And it's really interesting to sort of explore this more in depth and sort of get in front of one of the issues that a lot of our other panelists and other sessions have been exploring of, you know, the facility design considerations that had to be made in place when you're setting these things up. So it's really amazing to have a solution that can be so plug and play and adaptable to all these various different situations that you're discussing. So yeah, fantastic. Thank you both for that perspective on that side of things. We've got a bunch of questions still here on the Q&A board to dive into. So I'll skip forward a little bit and I'll focus on this question from Roland McDaniel. He's asking, what are the final products that you can make with this type of system? And maybe I'll throw that over to Jason first and then have Mark supplement on top of that.
Yeah, I mean, almost anything. I mean, obviously, a pre-roll is not going to come out of the bottom of the machine. That's from it. But you know, gone are the days of buying, you know, a CO2 rack for, you know, high terpene extracts, or, you know, maybe a portion of that extract goes to distillate, and then you have hydrocarbon extraction for, you know, hydrocarbon-like products, you know, these live resins. You know, we can extract from live product in Vitalis because we operate sub-zero at Subcritically. Like, this is really unique a way of using a Vitalis. You know, our purities coming out of the machine at the extraction level are cannabinoid levels of over 80%. And so with just a little bit of refinement, we see a lot of our products start to crystallize. We have customers that are doing sugars and crumbles and all these really interesting quote unquote hydrocarbon-like products that maybe if that's something you wanted to bring to market, you might have to buy a CO2 and a hydrocarbon machine. And then if it's all about just crushing through material, like you look at Christina Lake, you know, they're processing, was like 39 acres of outdoor product. And what used to, you know, they had one machine and pre-Cosolvent, their processing time was going to be something like 17 months. Like it would take them more than a full year to process what they cultivate. And now they're actually facing a scenario where they might actually be done already. You know, like they've got months of space that they can just buy product and load it with others. So if you're just crushing through material because your market is all about making really great distillate, well, I mean, you could buy a giant ethanol rig and, you know, running through thousands of liters of ethanol, but Cosolvent uses such a tiny amount of ethanol to accomplish basically the same process. So crush it through a Cosolvent machine. And if you want to make terpenes one day, do that. If you want to make distillate the next day, do that. You want to run live resin on the weekend because it takes forever, but it smells amazing and you can sell it for a fortune, do that too. And this is one of those points where, you know, you really are in a situation, unless you want to get into these really down the rabbit hole, really weird boutique products that require specialized processes that are only made one specific way, growing diamonds in jars. Okay, do that. But if you want to make like everything else, the most checkboxes for the number of SKUs you can make from a piece of equipment is on one of these.
Oh, fantastic. I saw you, Mark. It sounded like you had a perspective you wanted to get on that. So I'll turn it right over to you.
Well, I was at Christina Lake yesterday and they've had to buy in another 40% of product. They've used up all their product for the year, and they've had to buy in another 40%, and they could still process more. They are churning through stuff like all get out. And I have to say the quality of the product that I saw on the racks and that was just top shelf, like just amazing. Some of the development I'm seeing using this technology and what people are going back and making hash with it, they're doing combinations of the different extracts they're making and coming up with these traditional products using 21st century solutions. Andrew's comment about other co-solvents. Yes, there's a number of different other co-solvents, methanol, ethyl acetate. You could even use water as a co-solvent. So I do know back in the day they were using hydrocarbons as co-solvents with CO2 as well when the technology first started in the 1930s and 40s. So it's been around for a while in that regard, and subcritical's been around since the 1950s. So it's not super new, but this is a new twist on it. The other reason, why would you do this? This is tunable technology. That's really important in my world, in the aromatic world. I want to specifically target certain compounds in a plant and tune the extract. You can't do that with hydrocarbon. You can't do that with solventless. You can't do it with ethanol. What you get is what you get. They're very, very untunable. CO2 is tunable over time, temperature, pressure, and co-solvency. And by adjusting that co-solvency, you can adjust the polarity of the extraction medium to take specifically what you want, and more importantly, leave behind the things you don't want. And that video of the glunky total extract monosolvent versus the beautiful co-solvent extract. As a processing chemist as well, and a formulations chemist, I like co-solvent extracts because they're simpler to work with. You don't have all that wax, you don't have all that color, you don't have negative notes that you don't necessarily want there, or taste profiling notes that you don't want. So it just makes my job a lot easier to make beautiful products at the end and across the full gamut of whether it's cosmetics, internal pharmaceuticals, beverages, recreationals, the whole lot. And culinary, wow, it's even better.
Yeah, that particular visual aspect of the presentation was one that struck home for me so hard. I mean, you could just see it right there with your eyes. I mean, even if you're not a chemist or an extraction specialist, it's very obvious the difference in these two methods. I know we have one more question here that we haven't answered live, I believe. Yeah. From Antonio. He says terpenes can be extracted before the extraction process when they do drying. Or with your process, could their separation already be done during the extraction phase?
Yeah, so when basically you do a subcritical run to pull out those volatiles. So subcritical CO2 or liquid CO2 is perfect for pulling out your carbon 10, carbon 15 terpenes and other terpenoids, things like little luol, etc. It leaves behind the cannabinoids predominantly, but it leaves behind all the chlorophyll, it leaves behind the water, it leaves behind the wax. So you can actually put green flour into a CO2 rig and run subcritically to get those terpenes out. If you're specifically targeting some of those really unique terpenes that are like very floral or very fruity, they don't like being dried. They get broken down with heat. You don't want to put heat anywhere near them. So this is where the very low temperature, very low heat, liquid CO2 is the bomb in getting those out. Then you crank the system up, do your monosolvent run, and then introduce your co-solvency at whatever point you want to then clean it up and then basically switch it off, go back to monosolvent at the end to strip that biomass out so that it's clean and dry and can be disposed of. It can be turned into activated charcoal or mulch or whatever. Stock feed. There's a plethora of things you can do with it.
Yeah, it's an interesting scenario that I've seen many times before. Particularly capturing terpenes during the drying process. Cascade marketed a product. I think they still do, that kind of bolts onto the back end of their drying ovens to basically condense the exhaust so that any terpenes that evaporate during the drying process can be captured. But like Mark had mentioned, a lot of these terpenes that smell good are also extremely temperature sensitive. And so in a lot of cases, some of these terpenes just break down and they just go away. Other things too, though, is that during that evaporative process, you are also evaporating a lot of the very light aromatics that the plant has to offer. And these are a lot of those terpenes that you don't really want, right? Like there are some that kind of give you that characteristic of, like, some people might call it gas, like good gas though, like gassy skunk. But then there's like the actual petrochemical, naphtha, ether, gasoline type of aromas that come off very early in the evaporative process. And that condensation process that goes on the back end of drying isn't selective. It just captures all the moisture that comes out of the exhaust pipe and then turns it back into a liquid, and hopefully it smells good. So if that's a process that works for you, if you have a particular genetic that doesn't express a lot of those characteristics that are undesirable, and what's coming out of your condensation process downstream of drying is exciting to you, then by all means, I mean, there's natural curing drying that can be done. Like you go into a greenhouse, what does it smell like? It smells like cannabis. Why? Because a lot of terpenes don't need any help to extract. They extract with air at atmospheric pressure and temperature.
They're volatile.
Absolutely. But I would maybe challenge you to a little bit of experiment. Take some of that product that you've dried the way that you dry, and collect all those terpenes that you've collected through condensation of exhaust in the drying process, or in your drying rooms, in your dehues, and then run that dried material through a Vitalis, running monosolvent subcritical CO2 to do a terpene strip, and then try that out. Number one, there's still going to be a ton of them. So it's not like you can say, I extracted terpenes from my drying process, so I don't need to do terpenes in my extraction process. You absolutely do, because there's still a ton there. And those ones smell really, really good. And those are the ones you want to set aside and either formulate into your finished product after downstream distillation, or sell them to the ethanol guy down the street that can't make them at all.
The other thing you can do with that drying room type of product is put it back through a vacuum still with really good temperature control, and blow off the front end. Get rid of those what we call melodious terpenes, the not so nice smelling ones. You can just fractionate them off in a good still array. And yeah, as Jason said, most of the volatiles that we want stay in undamaged plant material. They stay within the trichomes. They're really good. In the aromatic world, they stay inside the leaves. And so you can dry plant material and not lose any terpenes, and then put them in a still and distill them, or CO2 extract them and get them out. So go and try, as Jason said, try it and see. I think you'll be pleasantly surprised, because what you're getting at in a drying room is not what you necessarily want. You might get something nice, but you'll more than likely get something that you probably want to put in your car for fuel or for cleaning your injectors. Be good for that. Not so good for perfuming.
No.
What was that other question we had in the registration area, Brian? You said there was one came up.
Yeah, I did. And I'm glad that you all touched on that. I love our audience members being given homework when they're leaving these programs today. So that's fantastic. Test it for yourselves. And yeah, we did get a few questions during the registration process that I've had here on the backside, just waiting to see if we needed to dive into them. But I think they're great. They're touching on some of the elements that we haven't really explored yet in particular. So the first of those questions was, if I want to run multiple solvents, might it not be less expensive and more efficient to use multiple machines? So can you touch on the benefits that this Vitalis system provides on that aspect of things, Jason, and Mark, provide your perspective as well?
Yeah, I guess I might want to understand the question a little bit more. And by multiple machines, do you mean like multiple smaller pieces of equipment, or do you mean like having multiple separate processes? I think what they meant was multiple separate processes. And the answer is like maybe. But in most cases, at least almost all the projects, 157 builds that we've done around the world now, where that in a lot of cases was kind of like a scenario that was considered. In almost no scenario did it work, because you have to kind of consider the products that you're trying to make, and then the processes that you're going to deploy to make those products. And if there is one piece of equipment that can make products, and by, like Mark had mentioned, you just turn a knob here, push a button there, and run this pressure, this temperature, this flow rate, you just change a couple of things and you can make completely different products. You've got one operator, you've got one SOP, you've got one cleaning process, you have one kind of set of downstream processes. If you have a hydrocarbon extraction process, then you need to have purging ovens, and you need to have a class 1 division booth, and you need to have safety procedures and people that are especially trained on that whole process tool chain. And then if you have an ethanol process, then you've got a centrifuge, and you've got giant chillers that are keeping that ethanol at -50 all the time. And you're storing that somewhere, and then you're putting that in its own safety space. And then you have huge falling films and all the power that goes into evaporating huge volumes of ethanol to recover it. And then you need to clean it, and then you need to reuse it, or otherwise your process is not going to be economical. And then CO2 and Cosolvent, every process has like this assembly line of processes that go into them. And yes, as you get past a certain point, so for example, in Cosolvent extraction, I load plant, I extract it, I then remove any residual fat and wax that might be there, and don't let anybody tell you any otherwise. There's fat and wax in ethanol extract, there's fat and wax in hydrocarbon, there's fat and wax in everything. But with Cosolvent, there's just such small amounts, it's almost a negligible process. And you basically get to a point where you are at a winterized high terpene extract, something you can put in a vape pen and sell as like a great all-around full spectrum experience. At that point, it then goes to distillation, and then it goes to gummy bears or your commercial kitchen to make cookies, or it's going to go to vape pens or put in an inhaler. Like when you get to distillation or get the end of extraction and its refinement, that's where processes start to split out into what is it that you want to bring to market. And if you want to make everything, okay, but be careful what you're trying to chew off, because there's a lot of people that have tried really, really hard and failed miserably by just spreading themselves super thin. Be like Christina Lake, be like some of the other big players out there that are really good at making like 3 or 4 things. I almost guarantee you that CO2 can make those 3 or 4 things. And if you want to make another couple of more things, you can probably make those on those CO2 machines. And if you want to have like a little, 2-pound butane machine in the corner because you want to grow diamonds because that's what the market dictates, then do that too. But to basically build 3 completely separate lines that have 3 completely separate safety procedures and SOPs and training procedures to make a lot of things that probably one machine can do equally, if not better as well. And at the end of the day, and this whole presentation was far more economical, then I would highly encourage you to do that.
The economics in cannabis have changed. The landscape's changed dramatically. When I first started coming to America in 2015, and I started talking to some of the CO2 guys, and they were saying, $25,000 a kilo, money, print money. And I said, you need to start diversifying, guys. You need to start looking for new markets. You need to start looking at other botanicals, because this isn't going to last forever.
You're not going to be the only one with that idea if that's what the economics are.
Yeah, and it's the same thing in everything. Look, I've seen this happen in the aromatic world. I've seen it in other farming practices. You get the boom, you get the bust, and then you get the people that were smart about during the boom. They invested their money, they built their procedures, they got goods, they got their core business up and running, and they ride out the bust, and then they come back strong in the rebuild. And that's where we're at now. We're in the bust phase. There's a lot of companies going to the wall. A lot of CO2 companies have gone to the wall in the last couple of years, and a lot of extraction companies have gone to the wall. A lot of farms have gone. There's a lot of shuffling around the world. This is happening, and it's normal. This happens all the time. I saw this with the tea tree industry back in 2000, when we lost so many farms and the price went all over the place. But companies, and I'll use Christina Lake as an example, companies like that are smart. There's a reason why they've adopted this technology, because it is really, really smart. It's simple. It means you can use minimal operators. Your cost of consumables is extremely low compared to other types of extraction, and it's a versatile medium. You can do lots of things with it, and that's what I'm noticing, that people are that they're learning from working with this gear, and they're tweaking it and going, okay, I can do more with this than just run one particular way. I can run this 10 different ways and get 10 different products. And that's exciting stuff to be working in. It really is.
Yeah, it's an inflection point in the industry that we really find ourselves in. And I don't fault anybody for saying ever that, yeah, but I can do it in insert process X. But I know, so can everyone else. So can the other 3 processors on the same block that are selling into the same market, trying to sell to the same thing that the same consumers are asking for every day. The economics are exactly the same. So unless you have free input material and you have free electricity and you don't have to pay for labor, everybody has the same economics they need to deal with. And unfortunately, in the market that we're in now, is that the products you're creating, compared to what all your competitors can also sell for, ultimately ends up having to either be beaten on incredible marketing or price. And that's really where we are. And if you're going to have all of these products that you can bring to market, and you're going to bring them to market at cost, because that's what it needs to be able to sell at retail, you're not putting yourself in a good spot. What's really important for people to consider now is, first, can it make the products that my market wants? Because it doesn't matter how much I can make. It doesn't matter what my throughput and volume is if it's making my product that my market doesn't want. But if it can make that product incredibly well, and like we said, a co-solvent extractor using CO2 can make a lot of checkboxes for a lot of SKUs, but it can do it far more economically than the rest of the guys down the street. Now you're in a position to play on price, do all the marketing, but actually put a few dollars in the bank and be profitable. Be open next year. Plant another crop next 16 weeks. This is the scenario that a lot of people just they're really passionate about their processes, and they don't consider the business fundamentals of running a cannabis business when it's not $25,000 a kilo anymore.
Yeah, exactly. I mean, we're all facing this new economic reality, not just in Canada, but across the US as well. I mean, we've been seeing the market contract, and all at the bottom line of all of these is that you need to get your cost of production as low as possible. And then, as you just mentioned, that actually expands your budget for other sides of things, such as marketing. So yeah, I think this last question that we did get during the registration process, which it seems like it's a good one to piggyback off of the point you both just made. I think it came from somebody that's more familiar with supercritical extraction methods, and wanted to get a little bit of more of an explanation on subcritical CO2 and its uses. And if that means that they do not need such high pressure equipment to engage in some of these other extraction methodologies.
The history of CO2 is that the Russians invented subcritical CO2 in the 1950s after they started playing with liquefied hydrocarbon gases, mainly for the food industry. Russia is unique in the world that all their food flavoring extracts are made with subcritical CO2. I got to see some of this stuff 20 plus years ago when I met a Russian guy came to Sydney in Australia, and he showed them, and I was blown away. And then I started digging into the history of it. Basically what happened was the Russians' subcritical technology was given to the English. They gave it to the Americans in the 1970s, and then they took it and they went supercritical. And there's a lot of good reasons why supercritical technology works the way it does. But particularly in the cannabis industry, I've noticed that people have got these ideas locked in their head that, oh, subcritical is rubbish, it's only good for terps. It's not. You can use subcritical CO2 with co-solvency and you get a better product quicker, more effectively, without all that extra crap in it that you don't want, than you'll get by doing a high pressure total strip everything out and then I'll clean it up later. That's the dumb part of it, is doing that. That's what we used to do in the absolute world, in the oleoresin world back in the 1950s and 30s. And it's kind of, to me, I've always looked at it and gone, that's just dumbass. Only take out of the plant what you want, leave everything else behind. And that's where co-solvency helps. Now, you may not want to use ethanol as a co-solvent for a number of reasons, but there are other co-solvents, and there is a plethora of academic literature on co-solvency. This system will run all the different co-solvents. You have to change some seals, you have to go to PTFE and the like, but that's not a problem. And that's the beauty of it. You can tune it to do exactly what you want and be effective in that. And that's gold. That's like, it's amazing compared to that sort of earlier mindset of we'll just strip the terps and then do this, and subcritical, it's rubbish, you don't use subcritical for anything else. Well, you do. It's a really simple, really useful technology. You may start to see subcritical water being used too, with supercritical water starting to be used more in extraction, particularly getting away from cannabinoids, but into antioxidants and some of the other bioceuticals. There's a big market there. A lot of research being done in this country and in America as well by researchers, John McKay, Dr. Jerry King. They've all done thousands and thousands of research papers in this area, and we're seeing more and more things using supercritical and subcritical technology. I mean, your coffee percolator is your coffee machine is a subcritical water extractor, right? Or supercritical water extractor, actually. So yeah, don't diss the technology. It's actually got some really good uses. Go and play with it. If you've got a supercritical machine, you can do subcritical. Go play with it and see what it brings out. I've got hundreds of subcritical aromatic extracts, and they are gorgeous. They are so useful in flavoring work, in therapeutic work, in cosmeceuticals, in nutraceuticals. It's not funny. So, anyway.
I have to like kind of draw with my hands. I'd love to have it up on the screen, but you can look at any phase diagram of CO2, and the states and the temperatures and pressures in which it lives in, a solid or a liquid or a vapor, or that kind of funky spot up in the top right corner, which is the supercritical. And like Mike had mentioned, you can do supercritical, you can do subcritical on most CO2 machines that weren't necessarily designed for it. Because in order to get to the supercritical phase, you have to be at least 1,071 PSI at 88 degrees Fahrenheit. You have to be both of those things. You can be really, really hot, but if you're not at 1,071, then it's going to be liquid. And you can be really low temperature, but if the pressure is high, so you have to be at both of those parameters, not one or the other. And so on most CO2 machines that have been designed commercially and into the cannabis space, most of them have, they really started to kick off with, what Eden was doing, and the guys over at Apex, Andy, the godfather really of commercially available CO2 extraction equipment for the industry, recognized as what that equipment was bought for, not retrofitted technology industries from other industries like a Waters machine. Absolutely capable of doing really low pressure extractions, but it's the temperature. The temperature is really the key. And when we saw, particularly through the 2010s and in the early 2010s, of CO2 chasing the wrong way, like, hey, well, if it goes higher pressure and it goes higher temperature, the process gets faster. It gets uglier until you get into 10 or 15,000 psi and 140 degrees. Like comes out looking like dirty motor oil. And they celebrate the win as like, look what I accomplished in less time. It doesn't fucking matter if people don't want to buy the product, right? So it's, can you make a product efficiently, effectively with less humans, less consumables, less electricity, but also still maintain product quality and consistency that either your customers don't know that the process has changed. The beer industry does this all the time. They'll use different extracts, they'll use different hops from different fields, from different seasons, but the end customer is expecting the exact same experience every time. So there's a lot of really funky things that happen on the back end to tweak that experience from farm to farm so that the recipe is always the same. But in CO2, a lot of the real magic happens subcritically, but below 32 degrees Fahrenheit, like below 0 Celsius. When you start getting sub-zero, like basically you're almost creating a hydrocarbon-like process using CO2 as the solvent. And so you get this really beautiful, CO2 gets stronger and more aggressive as a solvent, generally speaking, as you go up in pressure and temperature, which is why everybody chases the big numbers. But in actuality, it gets really weak. And then the addition of solvents and changing flow rates allows you to be more scalpel-like and do these really incredible, magical things. And like Mark mentioned, the real trick is make it an efficient extraction process, but can I make it be able to leave things behind too? Because when you figure that out, you've got a piece of equipment that the steel doesn't need to be as thick. I don't need to run it 10,000 PSI. I can run it 1200, right? Like, so the equipment doesn't need to be as costly, and therefore that ends up being a lower capital expense to you as the customer. The process is faster. So I don't need to buy a 100 liter. I can buy a 10 liter and accomplish the same amount of throughput per day. So now I don't have to buy as big and expensive of a machine. Like, all of these things get really, really interesting and exciting when you go the other way that no one has been doing. And Vitalis was like, there's got to be a better way. Lock the engineers in the windowless basement for a couple of years ago, say, don't come out until you invent something cool. This is what they create. And it's incredible what this equipment has been able to do for our customers.
Yeah, awesome. Well, that question really tied things all together, I feel like. So I'm glad that we got that additional question during the registration process. We're coming up at the end of the hour. So as always, I want to be respectful of all of our audience members and our panelists' time. But I typically do like to close out these programs by allowing each panelist to provide a final thought or a key takeaway from today's session. And if that final thought is just reach out to me to learn more today, that's totally fine. But I'll just turn it back over to Jason and then Mark to give us your final thought on today's program, and then we'll conclude.
Yeah, first of all, I want to thank everybody for their time. I know that everybody's time is valuable. Thanks for jumping on this call and listening to us babble about this really cool science and physics that we work on every day here at Vitalis. We ship, support, and manufacture equipment that goes all over the world that's used in all kinds of industries. So if you're not working in just cannabis, but you also have an aerospace company, you're trying to manufacture an aerogel, you're doing coffee decaffeination, protein defatting, we do just about everything. We're experts in a lot of different industries, with cannabis just being one of the largest ones. Obviously, we can't cram all of that into an hour. So by all means, our phone numbers and email addresses are right up on the screen there. So shoot me a call, a text message, an email anytime you like. Let's just hug it out about the way the industry is right now. But if there is an opportunity for us to help you in your business, let's take this offline and have a chat. We're happy to help out where we can.
Fantastic. Any additional thoughts, Mark?
I suppose my thoughts to the people in the cannabis industry is be open to new technology, to reimagining what's possible. I mean, and that's the biggest thing. Take the blinkers off. Look at the botanical world, which is so much broader than just cannabis. See the business opportunities in diversification of your extraction equipment. For instance, Cannabis is sitting at what, 800 to 1,000 a kilo at the moment for extracts, roughly, give or take.
Depending
roughly.
where you are.
Yeah, okay. Vanilla CO2, $14,000 US a kilo at retail. It takes 6 to 7 kilos of vanilla beans to make a kilo of CO2 extract. Why there's not more vanilla CO2 in the market for the vanilla market, I don't know. Why there's people are still doing it using ethanol. I'm trying to sort that out now and get other businesses up and running in this. But the minute you've tried vanilla CO2, you're going to go, why hasn't this been available? And it's the same across so many other plants, you know, and start thinking, how can I make use of this modern technology to make traditional cannabis type products like some of the other people we've talked about today are already doing? You know, I got to see some amazing products the last couple of days, and it's about reimagining what can we do now. Yes, they used to make hash, and they used to stick it under a bloody donkey's thing and ride it through the hills of Afghanistan to pack it. And we've got modern gear. Why don't we make new dose forms, new methods of enjoying these products and using them therapeutically as well as recreationally? So yeah, take the blinkers off. Be open to new ideas has been my thing. And Vitalis have some really interesting new ideas. And no, they don't pay me for this. I just love working with the guys because they have got some good shit. So.
Oh, I love that. As somebody that picked up baking during the pandemic, as I think so many others of us did, I could say that I'm eagerly awaiting that vanilla extract to hit the market and reduce my margins for making some birthday cakes.
Brian, I teach aromatic cuisine, food as medicine, where I teach people to cook using CO2s and other extracted materials. So watch this space soon. I'm in the middle of putting that online program together, but there's a lot of interest in working cannabinoids into the culinary and beverage space, but doing it really well, not doing it poorly like some stuff I've seen. You know,
wow, that's interesting. Well, I'm going to be eagerly following your feed now to learn more about that program. So thank you so much, Jason and Mark. With that, thank you so much to everyone else for, as always, participating in another NCIA Industry Essentials webinar. We hope that through this webinar, you were able to gain a deeper understanding of the the economic evolution of the legal cannabis manufacturing industry and its impact on today's producers. Furthermore, we trust that the insights shared have shed light on the drawbacks of different single solvent methodologies and highlighted the advantages of using this CO2 extraction with small amounts of ethanol as a co-solvent. As you proceed with your businesses, we encourage you to explore and implement the learnings from today's session to streamline your operations, enhance profitability, and most importantly, as so many of the panelists touched on throughout the program, maintain that consistent product quality that your customers should expect. With that, we conclude today's webinar, but NCIA's commitment to providing you with valuable insights and industry solutions continues. So we look forward to welcoming you back to future webinars. Thank you all so much. Me and the panelists are going to leave the stage, but feel free to stick around and interact in the chat room over the next few minutes while we highlight all of the sponsors of our annual Lobby Day event, alongside Vitalis, the sponsor of today's special session as well. So thank you so much, Jason. Thank you, Mark. We're going to head to the backstage and do a quick debrief, and then we hope to see you all again at a future NCIA webinar down the road. Thank you so much.
Thanks, Brian.
Right.